Good evening, everyone. And you've tuned in today to learn how to solve problems involving sample proportions. And I'm sure you're all just excited as this child is. And hopefully you have your note sheet in front of you. We're going to do two problems. I'll take you through the first one, and I'll show you all the steps that I would expect you to write out as you're answering the questions. Then I would encourage you to press pause and try the next one on your own. And then after you think you have your answer, then you can unpause and you can see the solution to the second problem. And hopefully after seeing these two, you will be ready to do some on your own for homework. So here we go. So here's the first question. Power companies kill trees growing near their lines to avoid power failures due to falling limbs in storms. I'm sure you can all remember the hurricane from last year. We had all that power outages. Most of that was due to falling limbs in storms. So this is one of the ways the power companies helps to keep this from happening. They apply a chemical to slow the growth in the trees. However, the chemical kills some of the trees, so that's a bad thing. Suppose that one such chemical would kill 20% of sycamore trees. The power company tests the chemical on 250 sycamores. You can consider these a simple random sample from the population of all sycamore trees. What is the probability that at least 60 trees, 24% of the sample, are killed? Alright, so here's how we're going to start this. Remember the four-step process from class today. So first, we're going to state the problem. All right, so what are we being asked to find? We're being asked to find the probability that at least 60, so we're being asked to find the probability that the sample proportion is at least 60, which is 24% of the sample. So the probability that it is greater than or equal to 0.24. So 24 is the smallest number it's going to kill. Alright, so that's what we're being asked to find. We're being asked to find that probability. Next up, we need to plan. Alright, so we need to think about what we know. Well, first of all, they're telling us that the chemical kills 20%. So that is the mean of the sampling distribution is 0.20. We can calculate the standard deviation of the sampling distribution by using the formula square root of 0.20 times 0.8, so 20% times 80%, divided by the sample size, which is 250. And this is the square root of all that. So if you put that into your calculator and let your fingers do the walking, you should wind up getting a answer, a standard deviation of 0.025. Okay, next up, we need to test our assumptions. The first assumption, I think it's safe for us to say, so we can say that it is safe to assume there are more than 2,500 sycamores. Now, I came up with that number of 2,500 because our sample size is 250. We have to multiply by 10, so that's 2,500. So it's safe to assume that. That's our safe assumption. Next up, we need to test our NP is greater than 10. So we would say N is 250, P is 20%. If you multiply those together, you get 50. So that's greater than 10. Check. And 250 times 0.80 is 200. Check. So both are greater than 10, or bigger than 10. Therefore, little triangle, we can say that the sampling distribution has approximately normally distributed with a mean of 20 and a standard deviation of 0.025. Okay, so now we've got it planned. Next up, we're ready to actually do the math. Alright, so then we're going to use our calculator, and we're going to do norm CDF, and we're going to calculate the probability that it is greater than 24%. So on your calculators, you would do norm CDF, with a minimum value of 0.24 and a maximum value of 0.00000, with a mean of 0.20 and a standard deviation of 0.025. Punch all that into your calculator, and the answer I have in front of me is 0.055. Now I also want you to always get in the habit of always drawing the normal curve. Right? So here's our 0.20. We want to know 0.24. So we're being asked to find that area. Right? And then finally, our conclusion. Our conclusion is that, right, it's asking us what's the probability that at least 60%, 60 trees, 24% of the sample are killed. We can conclude that there is a 5.5% chance that at least 24 trees, 60 trees are killed. That's it. That's all there is to it. So it's 4 parts. You always have to make sure and test all the parts, and you need to write them out. Alright, so I'm going to move on to the next slide. I encourage you to press pause, and then you can go ahead and you can do the next question. Okay, so hopefully you're back. You did it on your own, and you're ready to check and see how you did. So first off, reading the problem. It says, according to government data, 22% of American children under the age of 6 live in households with incomes of less than the official poverty level. A study of learning in early childhood chooses a simple random sample of 300 kids. What's the probability the proportion of children from poverty households is within 3% of the national average? So what are we being asked to find? So state. We're being asked to find this probability. So we're being asked to find that the probability that it's within 3%, so that means 3% on either side. 22% is the mean, so that means it's going to be 0.19 is less than or equal to p hat, which is less than or equal to 0.25. That's what we're being asked to find. Okay, so now we're going to plan. So what are they telling us? Well, they're telling us that the mean of all the p hats is 0.22. And we can calculate that the standard deviation is going to be the square root of 0.22 times 0.78 divided by the sample size, which is 300. Okay, so use your calculator, plug all that in, and I got an answer of 0.23. Then it is safe to assume there are more than 3,000 kids under age 6 living in poverty or from poverty households. I mean, when you think about the entire nation, 3,000 children under 6, I think that's a fairly reasonable assumption, unfortunately. Okay, so then we can test NP. So it's going to be 300 times P, which is 0.22, and that's equal to 66. And we can do 300 times N minus P, which is 0.78, and that's 234. Both are bigger than 10. Both are bigger than 10. Therefore, we can say that p hat is approximately normally distributed with a mean of 22 and a standard deviation of 0.023. Alright, so we tested our assumption, we made our plan. Next up, we can actually do the math. So we're being asked to find the probability 0.19 less than or equal to p hat less than or equal to 0.25. Plug that into your calculator. So if you do norm CDF with a minimum of 0.19 and a maximum of 0.25 and a mean of 0.22 and a standard deviation of 0.023, and you plug that in, and the answer that I got, let's see if you got the same, 0.078. And again, we want to always draw the curve. So basically that's the middle, that's the 0.22, and we're being asked to find between 0.19 and 0.25, so we're being asked to find that area. And so finally, last step is to conclude. We would conclude that the probability that there is an 80.8% chance that the proportion of children from poverty households there's an 80.1% chance that the proportion of children from poverty households, I'm saying that wrong, let me back up a second. Alright, see, this is the tricky part. Sometimes you have a hard time figuring out exactly how you're going to phrase this. So basically what you're being asked to find here, what's the probability that the proportion of children from poverty households in our survey is within 3% of the national average? So we would conclude that there is an 80.8% chance there is an 80.8% chance that the proportion of kids, the proportion of children from poverty households in this survey, in this sample, in this SRS, will be within 3% of the national average. Alright, I apologize for my handwriting. It's kind of hard to write on one of these tablets. But hopefully that clarifies some things on your thinking about how to solve these proportion problems. And if you tune in next time, we will talk about how to solve problems involving the mean. So I will see you in class tomorrow. Bye.